Artificial intelligence, a game-changer for archaeological discoveries. Imagine sifting through countless aerial photographs in search of remnants from ancient civilizations is a daunting task. For archaeologist Jesse Casana, this was not just a thought experiment, it was his reality. While reviewing thousands of images captured through drones and planes over the Middle East, he discovered unmistakable signs of ancient Roman forts. However, identifying these structures wasn't merely a matter of scanning. It required the keen observation and expertise of an experienced archaeologist, coupled with an immense investment of time. Archaeology can be approached from various angles, ranging from the minutiae of a single pottery shard to sweeping evaluations of entire landscapes filled with historical significance. Each level presents unique hurdles, but for Casana, the primary challenge lay in the sheer volume of data he faced. With a staggering count of about 400 forts already identified and thousands more still to examine, the repetitive nature of this endeavor was overwhelming. I've dedicated my career to this pursuit, and while I am proficient in spotting finds, this area is just too vast. I could definitely use some assistance. Casana reflected on the time-consuming nature of his work. In early 2023, as the socio-technological landscape began to shift rapidly, Casana encountered a promising solution. Although he initially attempted to recruit his students to aid him, those efforts fell short. While they approached the task sincerely, they often overlooked real forts and made incorrect assumptions about what constituted one. I found myself constantly correcting their analyses, he recounted, leading him to reconsider his options. That's when inspiration struck. A historical perspective on aerial photography. Did you know that the very first aerial images of an archaeological site were taken through the unique lens of a hot air balloon, specifically over Stonehenge? This innovative approach predates even the invention of airplanes. Archaeologists have long embraced the use of aerial photography as soon as opportunities presented themselves, evolving with the advancements in technology. The remarkable advent of Geographic Information Systems, GIS, provided researchers with a revolutionary tool by the latter half of the 20th century, akin to the traditional archaeologist's pick and hammer. Today, drones equipped with high-definition cameras are enabling researchers to explore areas that were previously impossible to examine. With the aid of thermal imaging technology, archaeologists can detect walls and stones that lie buried beneath the surface, thanks to their distinctive thermal signatures, which differ from the surrounding soil. Ground-penetrating radar, GPR, employs electromagnetic pulses to map subsurface formations, thereby revealing additional hidden layers on expansive plots of land. Meanwhile, light detection and ranging, LiDAR, employs laser beams to generate precise three-dimensional mappings of terrain, exposing concealed structures and features that might otherwise be lost beneath trees or soil. While archaeologists have been energetically gathering data from digital resources, the process remains labor-intensive and time-consuming. Prior to the widespread availability of AI technologies, there were efforts to train computer systems for discerning important points of interest from this data. The archaeological community was initially enthusiastic about the idea of delegating the task of identifying sites within the imagery to computers, Casana explained. However, early experiments did not yield the desired results. I was skeptical of these approaches and even published articles lamenting their inadequacies. Throughout his career, Casana firmly promoted what he called a brute force methodology, emphasizing that ocular analysis is key to uncovering valuable finds. Yet, he has come to acknowledge a significant shift in perspective due to advancements in artificial intelligence. I'm starting to regret my previous stance, particularly with the emergence of AI systems capable of learning from both human input and their own errors. As Emily Hammer, an associate professor specializing in digital humanities at the University of Pennsylvania, points out, training AI to identify specific archaeological objects presents difficulties, particularly due to the irregular nature of many ancient sites. Although certain temples share structural similarities, numerous variables exist across different locations and eras. This variability is a significant obstacle in archaeology, as the nature of past structures is anything but uniform, Hammer noted. Nonetheless, there are some instances where patterns exist. She has been mapping caravanserais in Afghanistan, ancient inns along the Silk Road that functioned as rest stops for traders, traveling between east and west for centuries. These caravanserais typically feature a common architectural layout, marked by grand entrances leading to spacious courtyards encircled by rooms, not to mention areas designated for the pack animals that assisted in transporting goods. This consistency aids in creating a model that is simpler to train, unlike other rarer types of structures. Hammer explained. Going beyond Afghanistan, her research into caravanserais opens the door for AI to assist archaeologists by combing through decades-old maps and photographs. They plan to utilize Soviet-era maps from the mid-20th century for future projects. Casana described them as incredibly detailed, promising a goldmine of data for cutting-edge archaeological studies. Additionally, declassified aerial surveillance images from that era can be instrumental in reconstructing historical landscapes that have been altered irreparably by the forces of modernity, such as agricultural expansion and urban development. The role of technology in expanding archaeological inquiry. This initiative is part of a broader set of projects supported by the Humanities and AI Virtual Institute at Schmidt Science, aimed at meshing artificial intelligence expertise with humanistic scholarship to illuminate chapters of human history. Harnessing archaeological-informed AI systems brings numerous potential benefits. Casana points out that it has the potential to drastically reduce the need for excavation projects. For many years, I conducted extensive digs across the Middle East. However, contrary to popular belief, an archaeologist's primary goal isn't merely to excavate. In fact, I wouldn't mind if I never had to dig again, as there are countless more effective methods of learning about history that don't involve delving into the earth. Digging can be problematic for various reasons. One is the ethical dilemma surrounding it. Many communities oppose disturbances to ancestral sites, and often these locations are situated on privately owned property, rendering them inaccessible. Once something is unearthed, it cannot simply be reburied. Mistakes can lead to irreversible damage. Additionally, excavation is not only labor-intensive and expensive, but also generates a massive influx of artifacts, each of which must be preserved, cataloged, and stored properly. As Casana aptly stated, with these new technologies, we can learn about past human activities without ever disturbing the soil. We document and analyze, taking away data while leaving the site undisturbed. That's how I envision modern archaeology should operate. While Hammer agrees that remote imaging and AI analysis will not completely replace the need for physical excavation, she acknowledges that these digital techniques offer a more condensed and sometimes misleading view of the past. Digital representations can obscure the complexity of historical development. They present a flat perspective. It may be challenging to discern whether what we see digitally was a burgeoning village or a shrinking city over time. Physically excavating facilitates understanding the chronological order of a site's evolution, helping to contextualize the materials uncovered in a way that is essential to grasping the development trajectories of ancient settlements or societies. As digital scholars, we recognize that our tools can illuminate significant aspects of the historical narrative, but we maintain the importance of physically experiencing the excavation process, Hammer argued. Blending various perspectives is essential to achieving an accurate representation of history. Furthermore, other critical elements demand attention, that AI and remote sensing technologies cannot fully grasp, Hammer points out. We must ensure that the interpretation of historical events involves the perspectives of contemporary communities, especially those who view these sites as part of their ancestral heritage. Ensuring human oversight is paramount to prevent reinforcing biases that linger in the archaeological profession today, according to Colleen Morgan, a senior lecturer in digital archaeology and heritage at the University of York, UK. In considering the integration of AI in historical interpretation, Morgan cautions against relying solely on its outputs to reconstruct the narrative of ancient societies. For many years, previous visualizations have perpetuated biases in representation, often depicting an incomplete view of humanity's complex past. To ignore the diversity of human experiences ignores the multifaceted nature of history itself, she remarked in a recent discussion on the topic. Hammer proposes that if applied judiciously, AI has the potential to mitigate certain biases. Traditionally, archaeologists have shown a preference for focusing studies on notable sites such as temples, opulent tombs, and palatial remains, occasionally neglecting the everyday experiences of the common person. AI could potentially assist in uncovering more subtle everyday structures, thereby enriching our understanding of the past. As Casana and Hammer move forward with their work on pioneering AI archaeology models, they emphasize that AI will not be given excessive interpretive power. Its primary role will be to swiftly process extensive data and highlight pertinent findings for human interpretation. I'll take the AI-generated information and draw meaningful conclusions from it, Casana noted. This reflects the core process involved in archaeological exploration, regardless of the method used. We may excavate and retrieve artifacts, but the true challenge lies in communicating the significance of these discoveries to society, he explains. Ultimately, it is humanity that breathes life into the remnants of our past, an insight he believes will always remain the domain of human understanding.